Okay, let's look at problem 1.8. This has the formula, and this is a real formula that Albert Einstein first worked out in his special theory of relativity, like it says up there. And it says that the mass of something depends on the rest mass. That's what typically you'd think of as your normal mass when we're at rest, when we're not moving, divided by the square root of 1 minus how fast you're moving. That's what v is, your velocity. Velocity squared divided by the speed of light squared. And he worked this out from really easy math, just algebra. It's actually real easy. We work it out in physics. It's real easy math to work out. He just sat down. It doesn't take anything fancy. And he came up with this formula. And because of this formula, he said, oh, therefore, you can't go faster than the speed of light. This is why. If you've ever heard that you can't even go the speed of light, it's all because of this formula that he just worked out using really simple ideas in math. Because look at this. Let's say you're going the speed of light. Then v is equal to c. If v is equal to c, this would be 1, right? V squared would be c squared. We'd have 1 minus 1 here, which is 0. And you'd be dividing by 0. And as you know, that's a no-no. You're not supposed to divide by 0. So therefore, he said, oh, I guess you can't go the speed of light. And even worse, what if you go faster than the speed of light? If you go faster than the speed of light, let's say v is equal to twice the speed of light, then your v here is 2c squared divided by c squared, which is like 1 minus 4c squared divided by c squared, which is 1 minus 4, which is negative 3. And then we'd have the square root of a negative number. Well, okay, we know you can have I, it's an imaginary number, so maybe in some imaginary universe that can happen, but we live in a real universe, we think. And so you can't go the speed of light or faster than the speed of light. And this is why. It's all because of this formula. It's pretty crazy. So they say in this problem, part A, okay, let's not go faster than the speed of light, but let's go 90% the speed of light, and let's see how heavy you are then. So the other thing is this formula says that your mass increases the faster you go. And we can see why that's the case. This number in the bottom here always has to be less than 1. We're taking 1 minus a number, and this number here is less than 1. So we're dividing by a number less than 1, like 0.1. If you divide by 0.1, that's like multiplying by 10. So if what's on the bottom here ends up being 0.1, we're divided by 0.1, that's like multiplying by 10, and your mass is 10 times greater. So this always will give you a bigger mass because you're always dividing by a number bigger than 1. So let's see how much bigger than 1. Always dividing by a number less than 1. So the goal here is to figure out what that number is. Okay, so first let's do v is 90% the speed of light. That means that v is equal to 0.9 c. Now they tell you what the speed of light is, but for this part we don't need to know it. We just need to call it c. Now they tell you that c is 3 times 10 to the 8th meters per second. But we don't even need to use that here. It's way easier to just call it c. So if v is 0.9 c, we just plug that into this formula for this, okay? If v is 0.9 c, then v squared, 0.9 squared, 9 squared is 81. 0.9 times 0.9, 2 decimal places. That would be 0.81 c squared. Now we can plug that into here. So this is equal to m0, which they say, let's say someone weighs 66 kilograms, multiply by 2.2 to get pounds. That's like 130 pounds or something. So 66 kilograms divided by the square root of 1 minus 0.81 c squared divided by c squared. Right? V squared is 0.81 c squared. Well, the reason why we leave it as c is because the c squareds cancel. We have a c squared on the top, c squared on the bottom. So this is just the square root of 1 minus 0.81. Well, I can do that in my head, kind of. That's 66 kilograms divided by the square root. 1 minus 0.81 is just 0.19. And now I can't do it in my head. I need to know the square root of 0.19. So let's figure that out. 0.19 square root 0.19. That's 0.4358. Oh my gosh. Doesn't really. Okay. I'm going to keep it on my calculator. 0.4358898. So that's equal to 66 divided by 0.43598. It's good to keep as many decimal places as possible again and round off at the end. 0.43588,989. 0.43588,989. That should be enough decimal places. 0.43588,989. Okay, so now let's just do that. So I get that has to be 151.4 about. So 151.4 kilograms. This is kilograms here. So when you're standing around, you're 66. When you're going really fast, you're more than double your weight, right? You weigh a whole lot more. You're almost triple your weight. And that's the truth. When you go faster, you get heavier. That's actually true. That's one reason why it's really hard, they think, to get a spaceship to go super fast. The faster it goes, the heavier it gets, which means it's even harder for it to go faster. It's pretty cool. Okay, now you do the exact same thing with the other ones. Here it's 99 and here it's 99.9. So here you'd say for the second one, you say V is 0.99c. V squared is 0.99 squared times c squared. You can, whatever that is, plug that in, do the same thing. You should get a number bigger than this because the faster you go, the bigger that number is going to be. It's going to be, I think, a lot bigger. Your mass is going to be even bigger. And then for the last one, V is 0.999 c times c, or V squared is 0.999 squared times c squared. So you're going to get an even bigger number. Okay, so I'll let you guys try that on your own. It's the exact same thing as what I did. You know, you take 1 minus whatever it is, 0.99 squared, and then 0.999 squared. Be really careful dividing by square roots and all that kind of stuff. I would show your work, show all the steps like I do. Don't skip too many steps because you're likely to make a mistake. Keep lots of decimal places in your calculator. And then you should get their answers. I believe they give you the answers so you can check and make sure you did it right. Yep, they do. So, okay, now part B. How fast should Dave be moving to have a mass of 500 kilograms? Now we got to do some algebra. Okay, so I'm going to erase this. So hopefully everybody's got it down. So now let's do the next part. How fast do you want to go? You want him to have a mass, I should say have a mass of 500 kilograms. So this is 500, so you say 500 equals 66, and we know this is kilograms, we know this is kilograms. 66 divided by square root of 1 minus v squared over c squared. We want to solve for v. We want to know how fast. We know what c is. They told us that c is 3 times 10 to the 8th meters per second. Okay. So I'm gonna leave it as c squared to the very end because that's a lot to write. So let's just call it c, and at the very end we'll plug in the number 3 times 10 to the 8th meters per second, and saves us a lot of writing. Okay, we need to solve for v. So this is algebra. First, well, there's no first. We can do this any way we want. Since we have a square root here, we're gonna have to square something. I want to put the numbers on one side and get the square root by itself. There's lots of ways to do this. So I'm going to swap these two. I talked about this, I think, in an earlier video. You can always take what's on the top here, put it in the bottom, what's in the bottom here, put it at the top. Or you can do all the steps of algebra, multiply both sides by the square root, divide both sides by 500. If we multiply both sides by the square root, okay, we get the square root on top over here. And if we divide both sides by 500, divide by 500, 500 cancels out, divide by 500, 500 cancels out, square root cancels out. We get the square root on this side and the 500 in the bottom over here. But again, it's easier to just think, oh, you can always swap these two. What's on the top here goes to the bottom, what's in the bottom goes to the top. So we have the square root of 1 minus v squared over c squared is equal to 66 over 500. The kilograms are going to cancel, so I can get rid of the kilograms. Don't have to worry about that. Now we square both sides to get rid of the square root. So 1 minus v squared over c squared equals 66 over 500 squared. So we're going to have to get a number for that. So that's going to be, who knows what it's going to be, 66 divided by 500 equals that, square it. I get 0.017424, which equals 0.017424. Let's see. Let's put the numbers on that side and the v squared c squared over this side. Okay, so I'm going to subtract this from both sides. Put a line here. So we're going to have 1 minus this on that side. 1 minus 0.017424 equals, this is negative on this side. It's going to make it positive on the other side. That's why I'm doing it this way. Equals v squared over c squared. Okay, so again, put the negative one over here, make it positive. Put this positive one over here, make it negative, leave the one where it is. Okay, so what's 1 minus that? I get that that's equal to 0.982576. 0.982576 equals v squared over c squared. Let's multiply both sides by c squared. Okay, so times c squared times c squared. So then those cancel. We get v squared. It's always nice to put what you're looking for on the left. So I'm going to put the v squared over here. Equals this times that equals 0.982576 c squared. And finally, we take the square root of both sides. Take the square root of v squared, we get v. Take the square root of all this, we get v is equal to square root of this number. I left it on my calculator, so I can do that real easily. Square root of that number, I get, oh my gosh, 0.9912497. 0.991249716. And the square root of c squared is c. Okay, last step is we now multiply times this. I think they want an actual number. So we're going to have to be going 99.1% the speed of light is what that's saying. To weigh 500 kilograms, we have to go 99.1% the speed of light. But they want the actual number. So plug in that. So we multiply that number times c. And I don't want to write this out again, so I'm just going to remember c is 3 times 10 to the 8 meters per second. You have to know how to put that into your calculator. You can put, there's different ways to do it depending on your calculators. One way to do it is just write out the number. So figure this out, how to do this in your calculator. Some things, there's a double E, you go 3 double E 8, that means 3 times 10 to the 8th. Some calculators work that way. You just need to figure it out. Or you can just put in 3 with 8 zeros. So 3, 1, 2, 3, 4, 5, 6, 7, 8. If that works in your calculator, some calculators you can't put in that number of zeros. Either way, I'm going to do that. I'm going to do this way, just for fun of it. I think this calculator can do that. So times 3, 1, 2, 3, 4, 5, 6, 7, 8. And I get 2.9737. Okay, it goes on really far. I'll just try to match their answer. How far did they go? They said 2.974. They kept 3 decimal places. That's what I got. So 2.974 times 10 to the 8th meters per second. Or you could put 2.974, extend it out 8 places that way. In other words, pretty close to the speed of light, pretty close to 3 times 10 to the 8th. It's not 3, it's almost 3, 2.974 times 10 to the 8th. Or like we said, about 99.1% of the speed of light. So you have to go pretty fast to weigh 500. That means that up above, when you put in 99% the speed of light, you should have gotten a number less than 500. This is 99.1. And you put in 99.9% the speed of light, you're going to get a number bigger than 500. And you do, they give the answer, so you can check that. Okay, a lot of algebra there. It's pretty cool because this is real physics. This is the way the world works. When you go faster, you actually get heavier. It's pretty awesome. All right, thanks again for listening.